Hello. Today I'm going to be talking about nuclear fusion and answer the big question, how advanced materials could unleash fusion energy? Well, to answer this question, we need to first understand what is nuclear fusion. Well, nuclear fusion is basically when two light atoms combine to form a heavier atom. And the reason for this is because a small amount of mass is lost during the reaction and are being converted into energy. Fusion releases more energy than chemical reactions, which is why the scientists are studying it as a future energy source. The sun, along with all the stars, are powered by this reaction. In the sun's core, hydrogen atoms are forced together under extreme heat and pressure and fuses to form helium. And there's a fusion that happens here on Earth, which uses the key ingredients deuterium and tritium. Deuterium and tritium are basically forms of hydrogen. Deuterium is naturally found in water, so it is very abundant and easy to obtain. However, tritium is much rarer to find in nature, but it can be produced using lithium. When deuterium and tritium are heated into plasma, they move very fast and collide. When they collide with enough energy, they fuse to form helium and release a neutron. This neutron carries most of the energy that we can later turn into electricity. This reaction is used because it requires less energy to start compared to other fusion reactions. Now, remember how I said when deuterium and tritium are heated into plasma, you probably don't even know what plasma is, so I'll explain. To make fusion even happen, hydrogen must be heated to extremely high temperatures. At these temperatures, the atoms break apart into charged particles called ions and electrons, forming plasma. Plasma is like different from like a normal gas because it is made of charged particles and it can be controlled using magnetic fields. Now, why is nuclear fusion important? Well, nuclear fusion is important because it powers the sun, providing heat and light necessary for photosynthesis, climate regulation, and vitamin D production. It is also responsible for creating chemical elements like carbon, hydrogen, and all that good stuff. Nuclear fusion can also provide safe and clean energy. It doesn't produce nuclear waste or emit carbon dioxide or any other sort of greenhouse gases into the atmosphere. And the reason for this is because it uses hydrogen as fuel, and hydrogen is found in water, which is very abundant. Now, this is not perfect. There's a problems with nuclear fusion. The first problem is that it needs at least 100 million degrees Celsius to heat. So one of the big challenges that scientists are facing is trying to bring basically the sun here on Earth, and they haven't found an efficient way of doing it just yet. Another problem is that plasma is very hard to control. And the third problem is that materials can easily melt or break, which is correlation with the first two problems. There are solutions for controlling plasma, although it is still very hard. The first solution is that there is a method called fusion. It uses strong magnets to hold plasma in place. Basically, in this method, uh, plasma is like contained inside of a machine called a tokamak, which is shaped like a donut. It uses 16 D-shaped magnets stacked on top of each other like pancakes, and it also uses these HTS tapes to work with the magnets. Uh, Basically, the amount's like 14 of them, and they put them in the center, and they put them like around. It's just in the center, around the D-shaped magnets that are stacked. Because the plasma is so hot, it cannot touch the walls, so strong magnetic fields are used to keep it suspended in the center. These magnetic fields act like invisible walls that guide the plasma in a circular path, and that's how they use magnetic fusion. There is also another solution called laser fusion. These are the most two common routes that people use to control plasma. This method is called laser fusion, also known as inertial confinement. In this method, powerful lasers are fired at a tiny fuel pellet from all directions. I think they say it was like 192 lasers that are being formed into, or not formed, being shot into these tiny fuel pellets. Basically, what it does is that these lasers compress the fuel very quickly and it increases its temperature and pressure until a fusion occurs. So it's like very short bursts of fusion explosion happening. But They found out that this method, where this fusion reaction produces more energy than the lasers put in. So this was a huge breakthrough in 2022. But however, this method is still challenging because it requires extremely precise lasers, and the reaction only lasts a very short time. So that's why most people are mostly using magnetic fusion. Moving on to the next slide called Materials Matter. Um, I'm going to be talking about the fusion reactor now. The controlling plasma and future fusion reactors are like two different things. Plasma is like something that you have to control, like in the middle, and a fusion reactor is like a something outside that's to help maintain the high stress and all those other stuff that the plasma creates. Basically, think of it as like TV shows. They show like a cube in the middle and there's electricity flowing, and then outside they have these little like shielded designs around them. Just think of the fusion reactor as like that. There are some special materials that are needed for a fusion reactor, though. Materials like tungsten, which helps protect the reactor walls because they can handle the high heat and resist the damage. And materials like lithium, which helps create the fuels, or helps produce the tritium fuel and also absorb energy from the reaction. And alloys and ceramics, which handle the high pressure and stress. Without these materials, a fusion reactor would fail instantly. But because our challenges with creating the fusion reactor, we still don't have nuclear fusion energy to this day. The challenge is that the current materials do not last long enough. So, improving on these materials is one of the biggest steps toward making fusion practical for society. Now, is fusion happening in the big 2026? Not right now, no, but there are over 50 companies that are working on the nuclear fusion, and there is like over $9 billion invested into this fusion as well. So, experts are believing that there are some reactors that could be made by 2030. And as you can see in the picture I've shown, that is what a fusion reactor looks like. It's very, very big. And in conclusion, fusion has potential to provide clean, efficient, and nearly unlimited energy. However, it still faces challenges, especially in controlling plasma and developing materials that can survive the extreme conditions that it faces. With continued research and advances in technology, fusion could become a major energy source in the future. Thank you for listening.